Hey everybody, it's me, Tommy V, your water doctor, and this is Water is the New Gold. I want to talk to you today about the pH of water. There's a lot of videos across the internet, people doing their own tests, making a lot of assumptions about pH and the quality of bottled waters and tap waters. I'm here to tell you that until you understand the nature of water and the nature of pH, most of this stuff is disinformation. There's a couple of important facts that we need to keep in mind when we are discussing the pH of water. The first thing is that over time, the pH of water is going to change. That's because the water molecule is what they call a dipole particle. Positive at one end, negative charge at the other end. Those charges cause water to absorb a variety of contaminants from the surrounding environment, and it will change the pH of water. This is why when you leave a dog bowl, for instance, outside, a few days later there's all kind of contaminants in the water and it's nasty looking, no matter how clean it was to start. So today I want to do a little simple test and show you kind of what happens to the pH of water when you subject it to different conditions. So we're going to do this with with the same bottle of water here, and it is a Kirkland bottled water, and I'm going to take a common low-tech pH meter, and we're going to put it in here and watch what happens. This water should have a neutral pH somewhere around 7.5, 7.4, a little bit on the alkaline side, I suppose. We'll watch this for a little bit. I don't want to bore you too much, but maybe what I'll do is check out, and then when the meter levels itself, I'll pop back into you. Give me a second. Hey, I'm back. So here we see the water's kind of settled out at a pH of around 7.2, 7.15. This is considered neutral water. Nothing spectacular. It's what you'd expect out of a bottle of purified water. But now, let's do a little crazy thing. I'm going to take this glass here, and we're going to stir this water up a little bit. And I'm going to take a stir here that I would much rather be stirring a cocktail, but it's not quite 5 o'clock yet. And let's put the pH meter in the same water. I got a button here. Let's turn this thing on for you and try to get this in front of the camera. And now you see that this same water is showing a pH of about 4.4. You ask yourself, how the hell could that happen? It was just neutral a moment ago. Well, the reason is because when I shook the water up, it absorbed CO2 from the atmosphere. That causes the formation of carbonic acid, and hence the pH drops. So if you were doing an experiment and trying to help people understand water, and you had a bottle that was shaken up and you took this, you'd say, wow, this is acidic water. This product's no good. They're advertising neutral pH, but I'm getting acidic pH. Well, the problem is with your methodology, not understanding water, not understanding pH. Before I leave this episode, I'm going to shut you down and do one more video. I got a glass in the back of me. You can't see it yet, but it's been sitting around in ice. We're going to put some water in here and in the chilled glass and show you how temperature can affect the same bottle of water. Oh, there goes my dog barking. So here we are. You can see the ice in there. I got a chilled glass. I'm going to take more of this same bottle. I'm going to put it into a chilled glass, swirl it around a little bit, and while it's in the ice and cooled, we're going to take our same pH meter and there we go. Put the pH meter in here, and lo and behold, I don't know if you can see this yet, but we have a very alkaline pH, 9.6 to be to be specific. Question is, what is the correct pH of this bottle of water? Is it neutral as advertised? Is it 4.5 as after we shook it, or is it 9.7? Is that alkaline? Well, the answer is it depends what you're doing to the water. It depends on your measurement. In this case, the chilled water slowed the particles down. It made the meter read pH a little bit differently. So the next time somebody tells you about pH water and tells you that a product is not good because of the pH, you need to question that and ask these questions. How was it taken? What was the pH methodology? And don't assume that because someone tells you the pH of the water is all over the place that a product is bad water, because that's not the case. If you want to measure the pH of water, you have to have a clean meter, and you have to sample that water very gently when you first open the container. That's about it. We'll see you soon.